All right, welcome to yet another exhilarating installment of the Algebra 1 videos. This is section 2, and this is solving systems of linear equations by substitution. In section 1, we had done this by graphing, and we're going to do this with an algebraic method. Okay, so what we want to do today, we want to solve a system of linear equations using substitution. We want to be able to interpret the solution of a system of linear equations in a modeling context, okay? So, here's what we've got. All right, we want to... When we solve a system of linear equations, usually what we want to do is we want to write the system of linear equations in slope-intercept form. We want to use substitution to create a one-variable linear equation. And then we want to solve the new equation and then find the other unknown value. Okay, so we've got these steps here where we want to isolate one variable, create a one-variable linear equation, solve to determine the unknown variable in the equation, and then substitute the value of the variable into the other equation to solve for the other variable, interpret the solution, then we want to be able to check the solution. So what we've got here is we have the situation where you've got Marcel starts running and gets a 3-mile head start on Jonah, who is riding his bike. The graph shows their travel. When does Jonah catch up to Marcel? So we're trying to find the time. So we want to find the time. So we want to find the time where Jonah catches up to Marcel. Okay, and so we want to, remember what we did in the last section, we found this point of intersection between those two. Okay, now when we want to find the time, okay, that's where we want to find an x value. So we want to find the x value. Okay, so what I want to do is I want to do this, we have these two equations. It's not really apparent as to when this happens, okay? We know it happens between 14 and 16 minutes, so it's probably going to be about 15 minutes, roughly. So what I want to do is this, okay? I have these two equations, okay? Y equals 0.1x plus 3, and then y equals 0.3x, okay? Now, both of these equations are solved for y. Okay, we've got y equals, this and y equals this. So I know that y is equal to 0.03x. So what I'm going to do, and this is the method of substitution, I'm going to take 0.3x and I'm going to substitute that value in for y. Because I know that y is equal to that, so if I see a y up here, I can replace y with what it's equal to in my other equation. So what I would do then is I would write 0.3x is equal to 0.1x plus 3, okay? And so then what I would do is I would then subtract 0.1x from both sides minus 0.1x. Those cancel out and add to 0. If I were to take 0.3x and subtract 0.1x, that's going to give me 0.2x, and that's going to equal the value of 3. Okay, now what I'm going to do is I'm going to divide this by 0.2, divide this by 0.2. So these end up dividing out, and we're left with x is equal to 3 divided by 0.2. So if I were to take 3 and divide it by 0.2, that's going to give me an x value of 15, okay, which is what I thought it was going to be, okay? So if x is equal to 15, then, if we wanted to interpret our answer, then we're trying to find, the time. When does Jonah catch up with Marcel? So we would say that Jonah, okay, catches up to Marcel at 15 minutes. Okay, and that's the answer. That's what we want to interpret from this. We want to take this value of 15 and say, okay, what does this number represent? What is it time? Is it a distance? Is it a, whatever. So, and then what we want to do is we want to, if we find the x value, okay, we can also figure out what the y value is. So what I would do is I would take this x value of 15 and plug it into either of these values for x in the other equations. So what I'm going to do is this, okay, and I'm going to kind of do both. I'm going to do it in the first, in this bottom one here first because it's a little bit easier. But I'm going to find out what y is, and y is equal to 0.3 times 15. okay? Now, if I take that and multiply it by 15, okay, then that's going to give me a value of y equals 4.5, okay? And so I have an x value, I have a y value, and my answer, okay, my answer is this. Okay, my answer, okay, if we were just solving this algebraically, would be the point 15, comma 4.5. Okay, and that's it. And if you come over here, all right, this is a value of 5. Okay, here's 4. Here's our point. Okay, it looks like it's about 4.5. So, it seems pretty reasonable. Okay, now I don't have to just plug it back into this original equation to solve for y. I can plug it into either of these. And I'm going to show you that. So if I plugged it into the top one, I'd get y is equal to 0.1 times 15 and then plus 3. So if I take 0.1 times 15, that's going to give me 1.5 and add 3 to that, and so I get y is equal to 4.5. So it doesn't matter which one you do, because you're going to get the same thing. But, that's the process, okay? So let's take a look over here, and let's say that we want to solve the system of linear equations represented by the tables, okay? Now, what we're looking for is a common x and y value, okay? We have x values from 0 through 3, and then same thing over here. But they don't share a common y value. Okay, so what I want to do is I want to solve this algebraically using the substitution method. Now, here's what I have. Okay, I have that y is equal to 5.5x plus 6. Now, what I want to do is I want to take this value here, 5.5x plus 6, and I want to substitute that value into y of the other equation. Okay, I have the value y here. Okay. And it's equal, and I know that y is equal to 5.5x plus 6. So I can take this and plug it in for y. So I would write it like this. I would say 5.5x plus 6 is equal to 6.75x plus 4. So what I would do is I'm going to subtract 5.5x from both sides. Okay, and that's going to give me 6 is equal to, what is that, 1.25? So 6.75 minus 5.5 gives me 1.25x and then plus 4. Okay, then I'm going to subtract 4 from both sides. All right, and so then I'm going to get this. I'm going to get 6 minus 4 is 2 is equal to 1.25x. Okay, if I divide both sides by 1.25 and divide by 1.25, okay, if I take 2 divided by 1.25, that's going to give me an x value of 1.6. So I know from this that x is equal to 1.6. Now what I need to do is I need to figure out what the y value is. Now I can take this and I can plug 1.6 into either of these equations and solve for y. So I'm going to do it into the first equation. Doesn't really matter. But I'm going to say, okay, well, y is equal to 5.5 times x, which x is 1.6, okay, and then plus 6. Okay, and I'm just going to evaluate this. So if I do 1.6 times 5.5, that's going to give me 8.8, and then add 6 to that. So we get 8.8 plus 6 is going to give me 14.8. Okay, now what I end up getting here is I get an x value and I get a y value. So my answer needs to be written as an ordered pair. And it needs to be written as a point, 1.6, comma, 14.8. Okay, and that's it. All right, that's my answer. All right, now on something like this where you're kind of going, all right, how do I know if I have done this correctly? Okay, one way to do it, and probably the best way, is to graph it. And I'm going to graph both of these in Desmos and see where they intersect. All right, so I've graphed both of these equations in Desmos, and I have found the point of intersection, and it turns out that we were right, that we should get 1.6, comma 14.8. So, if you understood the graphical method, which really wasn't too bad, in my opinion, I think that this will really help solidify and help you answer these questions, going forward. So keep that for consideration. Okay, this next example is a real-world example where we're trying to calculate and find the number of tickets sold. So what we have is as people entered the gym for a volleyball tournament, members of the pep club were selling $3 raffle tickets for a tablet and $4 raffle tickets for a gaming system. The number of $4 tickets sold was 4 more than 1/2 the number of $3 tickets sold. The pep club raised $636 from the ticket sales, and we want to write a system of linear equations to represent the given scenario. So here's what we've got. All right, let's kind of come up with something here. First thing I'm going to do is say I'm going to let x equal the number of $3 tickets, Okay, I'm going to let y equal the number of $4 tickets. Okay, now what I know is that the number of $4 tickets sold, so the number of $4 tickets sold was 4 more than 1/2 the number of $3 tickets sold. Okay, so I'm going to write this. I know that one of my equations is y is equal to 1/2 x plus 4, okay? And I'm just getting that the number of $4 tickets sold was 4 more than 1/2 of the number of $3 tickets sold. Now remember, when we talk about x and y, x is the number of $3 tickets. Y is the number of $4 tickets. So this is one equation. Now if I sold both of, when we sell a number of $3 tickets and a number of $4 tickets, we raised $636, okay? So I get this, I have another equation here that I'm going to call 3x plus 4y is equal to 636. Now what this represents, I have $3 times the number of $3 tickets, okay? If I add that to $4 times the number of $4 tickets, that's going to give me a total of $636. Now here's where the substitution part comes into play, okay? And there's a number of ways of doing this. When both of my equations were solved for y, it was pretty easy to set them equal to each other and solve. But what I'm going to do now is do kind of another method of substitution. Only one of my equations is solved for y. So what I'm going to do is I'm going to take this value of 1/2 x plus 4, okay, and I'm going to substitute that value in for y of my other equation. So now I'm going to do this. I'm going to rewrite this bottom equation, okay? And I'm going to write it as 3x plus 4 times y. But instead of writing y, I'm going to write what y is equal to. And that's going to be 1/2 x plus 4, okay? And then I'm going to set that equal to 636. Now what I have is I have an equation that is strictly in terms of x, meaning that x is my only variable in that equation, and I can now solve this equation for x. So let's go ahead and do that. All right, so I'm going to distribute my 4 here, and so we end up getting 3x plus 4 times 1/2 x is just going to give me 2x, and then 4 times 4 is positive 16, and that's equal to 636, okay? Now 3x and 2x added together, that's going to give me, say 5x plus 16 is equal to 636. I'm going to subtract 16 from both sides, and that's going to give me 5x is equal to 620. Okay, so now I'm going to take this and divide both sides by 5, okay, and that's going to give me that x is, 620 divided by 5 is 124. So I've sold 124 $3 tickets, okay? So that's what that means, okay? 124 $3 tickets, okay? Now what I want to find is I want to find also the number of $4 tickets. So if I take this value of 124 and plug it into x over in my other equation, it'll allow me to solve for y. So I've got this now. I've got y is equal to 1/2 times 124, and then I'm going to add 4 to that. So then I'm going to do a plus 4. So half of 124 is going to give me 62. So I've got y is equal to 62 plus 4, And so if I add those together, that's going to give me y is 66. And that's the number of $4 tickets sold. Okay, and this would give me the point, if I were to graph this, graph both equations, I would have the point 124, 66, okay? And that's what I'm looking for, all right? So now let's take a look at the final example here, and this is solving systems of equations using substitution. Now, in both of these equations, okay, I don't have an isolated variable, meaning that I don't have x equals or just y equals something, okay? So I've got to manipulate this a little bit. So what I'm going to do is this, okay? I'm going to take this equation here, x plus 4y, and I'm going to solve this for x. Okay, and I'm doing that because, this is an easy variable to solve for. All I need to do is subtract 4y from both sides, and I just get that x is equal to 1 minus 4y. Okay, now that I've isolated that variable, what I can do is I can take 1 minus 4y, and I can substitute that in for x of my other equation. So I'm going to get this, okay, I'm going to get 6, and instead of writing x, I'm going to write what x is equal to. And that's going to give me the quantity 1 minus 4y, okay? And then I'm going to subtract 4y, and let's set that equal to negative 15, okay? Now, if I multiply out the 6, all right, I'm going to get 6 minus 24y minus 4y, and that's going to equal negative 15. Okay, so I'm going to combine my like terms. I'm going to get 6 minus 28y, and that's equal to negative 15. I'm going to subtract 6 from both sides. So I end up getting negative 28y is equal to negative 21. Now, if I divide by negative 28 and divide by negative 28, that's going to give me positive 3/4. So y is equal to positive 3/4. Okay. Now, I'm going to take that value, and I'm going to plug it back into, okay, the y value here, okay, in my other equation. So then I'm going to solve for x. So I get x is equal to 1 minus 4 times positive 3/4. And when I do that, my 4's divide out, and I get that x is equal to 1 minus 3, which gives me negative 2. Okay, so x is equal to negative 2. So now, let's think about this. Okay, I have an x value, I have a y value. What this represents is a point on the graph. So my solution, my answer, okay, is going to be the point negative 2, 3/4. All right, now let's check this graphically real quick. Okay, I'm going to plug both these into Desmos and see what we get. Give me a second. All right, so when I graph this, what you guys can see is that the point of intersection is the same thing. We got negative 2 and then 0.75. The answer that we got algebraically was negative 2 and 3/4. 3/4 is the same value as 0.75, it's just the decimal. I hope you like this. I hope you had fun, because I'm having fun.